Module 2, Objective 6, explain the role of epidermal pigmentation and the association between UV radiation and increased rates of skin cancers. Skin color is influenced by two pigments in the epidermis. You have keratin and melanin. Keratin is a orange to yellow pigment that's found in orange vegetables. When one consumes keratin, it accumulates in the epidermal cells, the deep dermis, and the subcutaneous fat layer. Often, when people accumulate a lot of keratin, they eat a lot of orange vegetables, it can actually pigment their skin in orange color. It's not uncommon for children, infants, to actually pigment their skin. I know my own children had orange noses for several years because they were very fond of squash. Ultimately, keratin can be converted to vitamin A, which is required for not only the maintenance of the epithelia, but we use it in the creation of photoreceptor pigments in the eye. So eating carrots, good for the eyes? It is, because of the keratin. The other pigment that's found in the skin is melanin. Melanin is a red to yellow to brown to black pigment produced by melanocytes. They're stored in vesicles called melanosomes, which can then be transferred to neighboring keratinocytes. Darker skinned individuals have large, numerous melanosomes. And the role of melanin is actually to protect the skin from ultraviolet radiation. If you consider a cell, melanin tends to organize itself or arrange itself above the nucleus with respect to the main axis. And the idea is, as ultraviolet radiation hits the body, the melanin will help reduce the amount of ultraviolet radiation that actually hits the nucleus. Too much ultraviolet radiation can damage the DNA. And again, if you start damaging the recipes for the proteins in the body, it becomes problematic, and it's known to cause cancer. So ultraviolet radiation is very bad if we're exposed too frequently or to too much of it. When you consider skin color, populations who have a more melanistic, more a darker base skin tone tend to have evolved around the equator. Why? Because they had more intense UV radiation. So when you consider UV radiation patterns, you get a lot of intensity around the equator. As you move either north or south, that intensity decreases. So as populations migrated and they evolved further from the equator, they ended up with less melanin production, which gave them a lighter skin tone. So melanin protects the skin from ultraviolet radiation. And again, while small amounts of UV radiation are actually beneficial, too much of it can actually damage our DNA. It can cause sunburns, it can promote wrinkling, or even cancer. Here we have an image of a melanocyte. You can see that all those little dark granules within that melanocyte are the melanosomes, and the melanosomes can then be transferred to these neighboring keratinocytes. Two types of cancers that are common with respect to the skin are the melanoma. That is when one of these melanocytes lose control of their cell cycle and starts dividing very rapidly. And as that one cell divides, you get the formation of a primary tumor. Another one is a basal cell carcinoma. This one tends to be less noticeable because of its coloration. But both of these can be very dangerous if not caught early. So it's very important to go to a dermatologist and get your skin checked periodically throughout your life. Blood flow and oxygenation can also influence the skin color. Hemoglobin, which is a protein within the red blood cells, is a bright red when bound to oxygen. So when blood vessels dilate from either heat or the skin reddens. When blood flow to the skin decreases, your skin becomes very pale. And hemoglobin will turn a very dark red when it releases oxygen. This can result in a situation that we call cyanosis. Cyanosis is a bluish tint to one's skin. It can either be caused by extreme cold, heart failure, or even asthma. Anytime you have a decreased blood flow or decreased oxygen content to a particular body part, that body part can become cyanotic. Here we have a really extreme case of cyanosis. There's almost a mottled appearance, a splotchy appearance. This is obviously a very bad situation. There are some other pathologies that can discolor the skin. Probably the most commonly known is jaundice. Jaundice is due to a buildup of bile produced by the liver. And if it can't be, if you can't get rid of bile because of some type of liver issue, it actually builds up in our skin, and it can turn the skin, or even the whites of the eyes may turn a very yellow color. Jaundice is very common in individuals with any type of liver impairment, so hepatitis, cirrhosis of the liver from alcohol abuse. It's also quite common in newborns. Newborns, the liver isn't quite functioning 100%, and when byproducts of bile build up, it can actually lead to a state of jaundice. What is the treatment for jaundice? Well, in newborns, we simply put them under UV radiation. And as the baby is exposed to UV radiation, the sunlight actually breaks down the byproduct. Addison's disease is caused by a mishap of the pituitary gland. It causes it to release excess hormone called ACTH. And it has the effects very similar to MSH, which is melanocyte stimulating hormone. So it's going to cause splotchiness or increased dark patches, and it's very noticeable inside of the mouth. And then lastly, vitiligo. Vitiligo is the systematic loss of melanocytes due to an autoimmune disorder. So in cases of vitiligo, one's immune system actually attacks the melanocytes within the skin, and it kills them. So over time, you get this systematic reduction in melanocytes. The skin becomes very patchy, and then if it progresses long enough, you could actually lose melanocytes and end up with this third image here. So this same little girl had a series of shots taken over time, and you can see that vitiligo slowly affects her to the point to where it removes all the melanocytes within her skin.